Piotr.
Hi. Yeah, like I said, happy to be here. Am I able to share my screen?
Yes, apologies for the small delay, but hopefully it should be on time.
Okay, let's do it. Yeah, so welcome everyone, and this is going to be called Safe and Robust Smart Contracts in Inc. And the subtitle is basically a play on there's like this famous category theory book that I tried reading at one point and failed. But yeah, I think it sounds nice with the title. So a quick disclaimer here. This is going to be about smart contracts in Inc. Obviously, a bit of Rust, actually, the basics. So if you're new to Rust and Inc, then definitely this is for you. If you're already experienced in Inc, then actually this is not going to be for you. Maybe you learn something, well, hopefully, but yeah, this is actually intended as a beginner's guide. And of course, I'm going to be like presenting this from the Aleph Zero perspective, but actually everything about Inc is obviously applicable to using Inc on other chains such as Astar or Fala. But yeah, let's jump right in. And yeah, I always include this smart contract definition from Wikipedia. I like to keep my sources reliable, but really, the way I would think about smart contracts is basically programs executing on the blockchain. This analogy actually works quite well. The blockchain as a computer with a storage. And obviously, once you gain the powers of writing smart contracts, you can create dApps in areas such as decentralized finance, digital identity, which is quite hot recently, more like, let's say, real world use cases as supply chain or provenance tracking, or, well, quite a hot topic, certificates of ownership. So not only limited to collectibles, but for art, real estate, tickets, and so on. And obviously, you can come up with your own use case, not within these categories. There's a huge number of them. So why do I focus on or underline the robustness of the smart contracts? Because I came up with this, kind of I call it the grand theory of hacks, but it's really just a very simple thing. So I have a hypothesis that the exploit can happen in all of the places in your code when you cannot be 100% sure what the code does, right? And yeah, it's actually near and dear to my heart because I have a background as a Haskell programmer in functional programming. So I really like what Inc does with, for example, error handling, which we're gonna take a look at in a second. But as far as like general advice goes, I would, when creating smart contracts, actually any programs, but with smart contracts, actually there's a lot at stake oftentimes. I would watch out for not validating input, because you need to be sure that your contract is getting exactly what it expects. The contracts are getting user input, be that an actual human user or some other dApp or a web app or whatever. Then any operations that mutate the state of the contract are potentially risky. And again, we're going to see how Rust actually does some things to mitigate the risks here. And this is, yeah, I think we figured this out in like Web 2 programming a long time ago, that mutating the state is a risky thing. Here is where it gets more, risky maybe is not the right word, but where it gets more weird. So I claim that all of the places where the code repeats, especially in the context of smart contracts, like cross-contract calls, and you can have like loops of calls and so on, they are risky. Like when you look at the famous DAO hack and how it happened, like a basic reentrancy, but this is essentially what caused it. So yeah, the Haskeller in me would probably even make the language non-Turing complete to just be able to prove everything, but this is not realistic. So I think Inc is actually hits the right balance here. And again, using DAO hack as a motivating example, you can Google it. Any catch-all or fallback methods, or more specific, or more generally implicit operations, I would watch out for those. Like, it's better to be explicit. This is kind of like a slightly Pythonic philosophy, but I think it works well for smart contracts. Right. So as I mentioned before, I am going to present it from the Aleph Zero perspective. Of course, Inc is more universal than that, but my day-to-day work is around Aleph Zero, so this is what I know the best, and I know that the smart contracts work very well on Aleph Zero. Now, if you don't know Aleph Zero, it's a layer 1 proof-of-stake blockchain with some privacy-enabling features, sub-second, actually both block and finality times. So it's actually quite important from the dev perspective as well, right? And especially for your users, that stuff happens actually almost instantly. Very low transaction costs. So yeah, this is basically a fraction of $1 once you convert it to dollars, which is also very convenient if you're designing smart contracts. And yeah, of course, what we are going to focus on in this presentation are smart contracts in Inc. Right, so to kind of give you an idea where to start, if you want to start developing on Aleph Zero, here's some links. Of course, our landing page, the main website, it will contain links to all of the other parts, like 1 or 2 hops, and you can get everywhere. But this docs.alephzero.org is our main documentation, covering pretty much everything that you need to know in order to write and deploy a smart contract on Aleph Zero. Then this developer portal is basically a collection of useful links, be that to our own documentation or to websites of some cool use cases on Aleph Zero, or some tools like A0ID and Hackathon being just two cool examples actually. Testa0.dev is the address of the testnet developer wallet that you might want to take a look at if you're deploying on testnet. Then this contracts UI, basically it's a graphical user interface for deploying and interacting with smart contracts. We're gonna take a look at some screenshots later. Again, very convenient. And something we get asked quite often, and it's been already answered in the chat much better than just posting a link here, but like the very basic way of talking to your smart contract from your front end would be the Polkadot.js API. So you can check it out. As mentioned, there's also use Inc, there's Hackathon. So yeah, there's a lot of possibilities here. Now, speaking about Inc specifically, this very small table attempts to give you an overview, like why would you want to use Inc over some other smart contract languages. So a great feature is that Inc is actually not a separate language. It's an EDSL built on top of Rust. If you are not familiar with EDSLs, these are embedded domain-specific languages. So putting it in more accessible terms, it's basically a subset of Rust with some macros specific to smart contract development, actually hiding a lot of, if not most of, the complexity from the developer. Now, being this subset of Rust, it inherits Rust's benefits. We're gonna take a closer look at, for example, memory management real soon. But, well, as we all know, Rust is a modern language, type safe, memory safe, with good tooling and universally liked. You know, all the Stack Overflow surveys point to Rust being the developer's favorite recently, and compiles to WASM. So not only to WASM, of course, but in context of smart contracts, we compile it to WASM, which is WebAssembly, which is, you know, ubiquitous, fast, and secure. Yeah. Now, this huge table is actually taken from use.inc website. and it's not meant to be studied during the presentation. Rather, it's I treat it as a picture that kind of confirms what I'm saying. And what I'm saying is that actually ink and solidity are quite close conceptually, right? So ink has its own way of doing some stuff, very, very convenient for us developers in most cases. But when you're switching over from solidity, it's not like you're learning an entirely new concept. So most of the things will feel familiar, and you will be able to transfer your skills with slightly different syntax, maybe with some cool new language features that make the development easier or safer, actually, as we're gonna see. But in general, you should be familiar with all the concepts. Like actually, one of the important differences to smart contract developers is the storage entries, which in EVM are 256 bits, and you cannot change it. So this is just the size that you operate on, like the machine word size. While in ink, it's variable, which actually can give you considerable performance benefits. Yeah, but other than that, pretty much any concept you're familiar with from Solidity, you can use in ink. Again, maybe in a slightly different flavor, but you should be good making the switch. And as we're gonna see soon, well, you will decide, but I think it's worth actually making the switch. Now, this again is more or less a picture attempting to give you an overview. And how do I start? Well, first of all, you install some dependencies. Actually, don't read too closely into the dependencies I install here, because they change quite frequently. I took it from some dark corners of my bash history, but right now I feel like you would install a slightly different toolchains, for example. But in general, you will need Rust, which will also install Cargo, which is like this package manager for Rust and build tool, if you're not familiar. You will also need to install Cargo Contract, which is this, let's say, extension of Cargo specifically for smart contract building, managing, deploying, uploading, and even calling the smart contracts. Now, once you're equipped with Cargo Contract, you will basically bootstrap your application with Cargo Contract New. And this is, to similar effects, for example, as Rails bootstrapping, meaning that you have a fully functioning, very simple, but still smart contract. And this is actually kind of important, because you're going to see very soon some scary looking macros, but you actually pretty much never type them out by hand. This just comes with the batteries included with what's being bootstrapped. So you just need to write your logic. So yeah, once your code is ready, you can, of course, test it and then build it. And once you do, you're left with, well, with two artifacts, actually. One is the binary code, and the other one is the metadata. And yeah, my small joke here is that you actually have a third one, right? Off by one errors, but the third one is for convenience. They are bundled together in one file. That's because when you look at the pure WASM blob, you don't necessarily know what's what and what to call and what it does. So this is why you need this metadata, also sometimes called ABI, to basically instruct both the users and the applications how to call specific methods, or as we call them, messages of your contract. Yeah, so word of advice and something found through quite a lot of trial and error is because inks is a fairly quickly changing ecosystem. So sometimes, there's a lot of moving parts, and it's not necessarily trivial to find a combination of versions that work. And two combinations that I found to work for me are, and which whether you choose the left one or the right one basically depends on where you want to deploy this. So for example, if you want to deploy on the Aleph Zero testnet right now or mainnet, you would use the left one. So a slightly older Rust, slightly older cargo contract. And yeah, I tested it with Inc 4.2.1. And this will actually change quite soon with the new release, and you will be using the right one. So oh, and of course, you don't have to deploy on any network right away. Actually, a very convenient way to develop is by using Substrate Contracts node. So yeah, so if you want to be on the bleeding edge, I would say that the right set of versions is the one to go with. Rust 1.74, Cargo Contract 3.2.0, and then the newest Substrate Contracts node and Inc 4.3. And now a word of advice, you may want to include this equals sign before the version number if you write it in your cargo toml, which is like the package versions file. That's because, like I said, the versions are uploaded quite frequently, and what this does is it fixes the whole version down to even the patch version, which probably will make your builds a little more reliable. At least that works for me. So yeah, moving on. You might have seen this, so it's probably getting quite old as a joke, but let's make a PSP22 token, which is actually a Polkadotized version of the ERC20 standard. I'm calling it Pete coin because I'm Pete and it's a coin, so it makes sense. Now, this is more or less what the ERC20 standard looks like. So simplifying a bit, but it basically just defines an interface that your contract needs to implement in order to be treated as a run-of-the-mill fungible token, right? So some of the methods here or functions are pretty self-explanatory. So total supply will give you the total supply, the total amount of tokens in circulation. Balance of a specific account will give you the balance. Transfer, of course, will transfer the tokens from you to someone else. And now this allowance, approve, and transfer from, we're not gonna focus on that in this workshop to keep it reasonably short. But they're basically for situations where you want to allow someone to make transfers on your behalf, which can be used, for example, if you're interacting with a DEX or something like that. And then the standard also defines events that are emitted when certain actions happen. Now, without further ado, once we bootstrap our contract with cargo contract new, this is basically the first line that we see, or well, first 4 lines actually. So you need this macro on top, which basically is necessary because Inc doesn't use the regular Rust standard library. But this is the same for all of the contracts you write. I have never actually typed it out. It was always generated for me. Then, very importantly, the smart contract as a whole is basically a Rust module. And you can think of the Rust module as basically a collection of things. Rust modules are way less magical than modules in some other languages. So like in Python, you can do pretty much arbitrary logic on module load. In Rust, this is not the case. It's just, it's more similar to a namespace in C++, actually, if you're familiar with this language. But importantly, for this to work as a smart contract, you need to prefix it. Well, yeah, prefix, kind of. You need to put the Inc contract macro on top. And it actually does a lot of stuff like behind the scenes. But basically, it allows this code to be treated as a smart contract and deployed as such. And you've probably already noticed that in Rust, the macros start with this hash sign. They are not comments. If you're coming from like Python, this might be counterintuitive, but they are macro invocations. Now, yeah, I formatted the code very poorly here, but okay, moving on. Every contract needs a storage struct to keep track of its internal state. In our case, the storage is going to be quite simple. We define a Rust struct, and if you're new to Rust, again, I'm gonna like throw in remarks like that. If you're new to Rust, structs in Rust are actually kind of like structs in C++, or like I don't want to say classes in object-oriented languages, but kind of similar. So they define this struct with some fields that you can access by name, and that's more or less it. So you can also attach behavior to the structs, but keep in mind that there's no inheritance of structs in Inc, which is, in my opinion, a very good thing. Now, for the struct to be considered the storage of the contract, you obviously need to put the Inc storage macro on top, which will basically instruct the compiler how to lay this all out in memory. And if you remember the Inc contract macro we included on top, it actually requires every contract to have exactly one storage struct. You can make it as complex as you like, but there needs to be exactly one. So 0 doesn't work, 2 also don't work. And now inside of our storage struct, we're going to keep track of the total supply of the coin or token we're creating right now. And of course, a mapping of balances. So this is like a very basic, balance sheet like you would have, I don't know, in a bank. So this is a mapping between account IDs of individual contracts users and to their balances, right? And yeah, in order to use the mapping like so, we need to also put the use I don't know, statement directive here, which will basically, what it will do is it will bring the mapping name into scope. We could actually skip this altogether and just write the Inc storage mapping in the balances line, but it's a bit cleaner this way, because we're going to use it later. So to not type the same thing 7 times, it's just easier to use it once at the top. And the thing to keep in mind is that the use in Rust and in Inc by extension is fairly non-magical. So it also doesn't do anything behind your back when you're importing this. It's actually, you can think of it as bringing the name into scope and nothing more, right? Now you'll probably notice some balance and account ID types that we have neither imported nor defined here. That's because the Inc contract macro is doing that for us, because these are very common types. So account ID is basically the account as you have them on the chain. It's actually the very same account format and everything. And the balance is basically a type alias for an unsigned 128-bit integer, right? Oh yeah, and the mapping itself is a bit similar to hashmap, but optimized for smart contract storage here. Yeah, so now that we have the storage struct defined, we can attach some behavior to it and actually write our smart contract logic. So the way you do it in Rust is you basically write impl, short for implementation or implement. I'm not sure, but definitely something in this area. And the name of the struct you're implementing this for, obviously. And this syntax can get quite involved if you're doing like generic types and type bounds and whatever. But here we are just doing this in the simplest way possible, just impl and the name of our struct. Now, this Inc contract macro I was talking about, one of the things it also requires the contract to have at least one constructor. And what is a constructor? Well, basically a constructor is any public function marked with the inc constructor macro. So this is quite important for us smart contract developers, because it actually doesn't matter what's the name of the constructor. So like usually people will call it new, but you can actually call it anything that makes sense for you, like initialize or create, or I don't know, you name it. As long as it makes sense for you and your users, you're good to use it. And yeah, you can have an arbitrary number of constructors. Now, obviously, this constructor will have to actually construct our struct. So this one here and all the other ones will return self, which is, you could also actually write Pitcoin instead of self here, but writing self is arguably a bit cleaner and more generic. Now, usually the PSP22 tokens take a bit more params, but here we are doing like a hugely simplified, stripped down version to make it easily readable. So we'll just take the total supply, and well, first thing we're gonna do is we're gonna actually initialize an empty mapping by using the default method. Maybe a bit more about defaults later, but yeah, this balances line will basically give you an empty mapping. Now, we need to know who is calling this constructor. This will obviously be the deployer of the contract, the owner, and we can do it by calling this magic env method, which basically gives us access to a lot of stuff about the contract's execution environment, including the caller, and you see the example on the screen. And now it makes sense that if I'm creating my own coin, initially I get the whole supply to myself. I can later transfer it, sell it, whatever I want to do, but at the moment of creation, all of the supply is mine to do what I want. And yeah, the way we kind of assign the balance here is basically inserting an entry into the balances mapping. So the mapping has an insert method that works exactly as you would expect. And so yeah, so we're basically inserting under the caller key. This has the right type, the account ID, and we're inserting all of the total supply to the creator of the contract, and then we're just returning an instance of this struct with the fields set to appropriate values. This is actually a shorthand syntax. Normally, you would also need to write out the names of the fields, but incidentally, the names of the fields are the same as the values we assign to them. So Rust allows this special syntax, and also, yeah, if you're new to Rust, you may be surprised that there's no return keyword. So the default in Rust is to basically return the last expression in the function. So importantly, expression, not a statement. So if you by mistake include a semicolon after this last line, you will return like a void in some languages, or like a unit value in Rust. So yeah, you need to keep that in mind. Now, yeah. Oh, you've probably seen this ampersand here when we were inserting into the map, and this is basically called. Well, this is something very similar to passing by reference in other languages. In Rust, this is called borrowing, and yeah, this leads me to a short explanation of Rust's very elegant and performant memory management system. So yeah, I sometimes include these subtitles here that attempt to be funny. I don't know if they succeed. You will be the judges of that. But essentially, Rust is not using a garbage collector because, well, garbage collectors have their own problems. Like they introduce some performance overhead. In the worst cases, they can actually stop your application if they feel like the garbage collectors needs to happen. This is something that used to happen in Java, for example, even for like enterprise applications. It was a huge problem. It has since been improved vastly, but still, garbage collection is not ideal. And Rust system is actually way more foolproof, maybe is the right word, than, for example, smart pointers in C++, and definitely easier to use than manually managing your memory. So basically, the way it works is Rust is using this ownership model idea. So every time you allocate a piece of data on the heap, importantly on the heap, right? Because if it's on the stack, then doesn't matter. But when you allocate something on the heap, it is assigned exactly one owner, right? And you cannot access data you don't own, or, as we're going to see, or that you have not been borrowed. So what I mean by owner here, right, it might be a bit counterintuitive. Like, what do you mean owner? Like, I own the code. And the owner here is basically, you can think of that the owner is a certain scope. So if a piece of data was declared and initialized in a certain scope, then this scope is the owner. If you try to access it from a different scope, so let's say from some function, you won't be able to. So now, of course, this alone would be very, very restrictive. Fortunately, you have this very elegant model when you can transfer the ownership, and either permanently or temporarily. And the permanent transfer of ownership is called move semantics. And this is very similar to passing by value in a lot of languages. So basically, you stop owning the data, and the scope that you moved it to will now own the data. We will see an example. If this doesn't make sense, we will see a motivating example very soon. And the other way is basically borrowing. So borrowing is basically like passing by reference, and it's basically instructing the compiler, okay, I do own this piece of data, but I'm borrowing it to someone else to use for a while, but then I expect it to be returned to me, right? And this is quite cool because it allows Rust to be actually fully memory safe. The checks happen at compile time, so they don't introduce any overhead during runtime. Right? It's not exactly true that Rust is fully memory safe, because you can do some unsafe operations, but pretty much you have to be very explicit about being unsafe, and which kind of makes it safe in a way. Now, I promised an example, and here it comes. So let's say we have this struct called foo with just one field. Doesn't matter what it is, actually, for the sake of this example. And in the main function, we instantiate it, we create it, and then we have this function pass by value that attempts to do exactly that, pass the argument by value. So normally in Rust, passing like that would mean that you give the foo instance away. This main function no longer owns it. Now the pass by value function owns it. So yeah, it does something with it returns the value of the field plus one, whatever. But then we discard the result, doesn't matter. But then we try to print the field of the struct in the main function. And I included a spoiler here. This should like appear one by one, but we get a compilation error, right? And the compiler here is actually quite cool in a way that it tells us what's wrong and how to fix it. So we get this borrow of moved value. So we moved the value to the pass by value function, but then we try to use it in the next line after moving it. So the compiler says, hey, this is not right? You've given away the value and now you try to use it. This is uncool. And so the way to fix it, one way to fix it would be, as the compiler suggests, implement the copy trait. So this basically allows you to not move the value, but move the exact copy of it, which works for some types, and for some types you do want to implement it. Pretty much for simpler types that don't incur this much overhead, but for complex types, it's usually better not to do it unless you have a very good reason to. So basically, we will fix it the other way. to passing this by reference or borrowing. So now we have the same function, but well, similar function, same struct, but we modified it a bit. Now instead of taking the foo struct as an argument, it actually takes the reference to the foo struct. So in the Rust lingo, it borrows it, and it borrows it and tries to increment its field. Right? That's cool. We should be able to do it, and we should be able to print the value afterwards, right? Because we did this pass by reference function borrowed the struct and then finished and of course gave it back. But the problem is we still get an error because, and again, the compiler here is quite helpful and quite polite at that. It says, well, the reference is not a mutable reference. So you cannot mutate the struct you borrow, which actually makes sense, right? If I lend someone my car, I don't want them to like change the tires or whatever. So this actually makes a lot of sense. And yeah, the compiler suggests what we should do if we really want to mutate this, what's under this reference. We have to be explicit about it and say, okay, change the reference to mutable, so that it's very explicit that you indeed want to mutate it. And if you think, well, it should be impossible to mutate a struct without wanting to, well, I would argue that in a complex code base, it's more than possible. So okay, we do just that, and we change the reference to mutable. Oh, there's a small error here. It should be plus equals 1 in the pass by reference function body. Sorry about that. But now it should work. It should work. So great. Basically, now you know that if you want to just pass a value somewhere to be modified for a while, you'll need to pass a mutable reference. If you just need to pass the value for a while, but you don't need to mutate it, use a regular reference. And if you want to just give the value away, it's safe to just pass by value /move. Yeah, I hope this made some remote sense. So we can go back to our actual contract. Now, one of the other things that the in contract macro enforces is that the contract have at least one message. So what is a message? Message is basically a method on your contract struct that's callable from outside of the contract itself, right? So you can think of this as basically a public API. So the public API will be just the messages and the constructors, and yeah, this should work. So you need at least one. Now, of course, you can include methods here that are not messages, and then they will be only usable by the other parts of your smart contract, but not by the external users. Okay, so well, we define a message by, of course, starting out with the inc message macro, sure enough, and then the method, the function is defined just like a regular Rust method, but it needs to be public. And actually, well, since I'm using functions and methods interchangeably, but technically I believe these are methods because, well, you have this self, which is self first argument, which is basically the struct that you're calling this on. It's actually interesting because the dot you use to self dot something, or the object name dot the function name, it's actually a syntactic sugar, nothing more. It's just a syntactic sugar for passing the instance you're calling this on as the first argument. And in Python, actually, they can be used interchangeably. So probably, yeah, worth keeping in mind. There's very little magic involved here. But importantly, the self argument needs to be passed as a reference. Mutable or not, that's up to you. But it needs to be passed as a reference to the function, to the method. It won't work if there's no ampersand in front of self. You'll get an error, so you'll know. Now, the total supply is just a simple getter. So you just return the total supply, simple. Then actually very interesting stuff happens inside the balance of method, which just takes, the self argument, obviously, but the who. In the standard, I think this is called the owner. I just changed it to who here because owner can be a bit misleading. So the balance of someone, and this is an account ID, so we can just directly look it up in the balances mapping. So we do it using get. Also, it expects the reference, so we just take the reference to this who param. And now what this will return is not the value directly. So some languages, when you try to access a value, might just give you the value directly. And if it's not present, for example, throw an exception, which actually would be suboptimal here. What Rust instead is doing is it returns this so-called option type. So option type can be one of two variants, either sum and the value you requested, or none and basically signifying the absence of any value. Now, since we want to return the balance here and not some option of balance, we use this unwrap or default method. And it's pretty cool because it says, okay, if there is something returned, so the sum variant, just extract it and return what's inside this box. And if not, return the default value for this type. And conveniently, the balance type or the U128 type has a default value, which is 0. By the way, pretty much all numeric types will have 0 as their default value. All collections will have empty collection as their default value. And yeah, this we'll see how this plays really nicely with the whole balances semantics and sending someone coins and whatnot. So yeah, just notice how this is really bulletproof, type safe, and everything. Really cool. Now, for the interesting part, well, the transfers, right? You want to be able to transfer the tokens to someone. And the way we do it is actually very simple. And this graphic is probably totally over the top here because the concept is so simple, but still, I think it looks nice. So I included it. Now, the transfer works in the following way. There's actually very little magic involved, which is a very good thing when it comes to, like, let's say, maybe not financial, but like transferring some value. So we have Alice and we have Bob. Traditionally, they each have 1,000 of the coins we're creating, Pete coins in this example. And when we want to transfer some value, let's say 100 PC, what we do is we basically, of course, we check whether the sender has enough funds to actually make this transfer. Then we subtract from the balance of the sender and we add to the balance of the recipient, right? And just like that, the transfer is done. And now we have this method here. And there's actually a few interesting things here. So the signature of our method just wants me to specify who am I sending my funds to and the amount I'm sending. In the actual standard, there's actually one more param and so on, and the errors are a bit different, but that's the gist of it pretty much. So what I'm doing is, well, first I need to figure out who is me, who is the sender. So I'm again using the caller, the nth caller magic method. Now I need to check the balance of the sender, and I use the balance of we implemented like two slides back. And now, if the balance is less than the amount I'm trying to send, then obviously I need to get this error about insufficient balance. And we're going to see in just a moment how to implement these errors and why they're really cool and help you write robust contracts. Now, but assuming this was not the case, so I had enough funds to send them, I will basically subtract from my own balance. And the way insert works is it just overwrites, right? So in some languages, you might have the slightly different semantics of insert. Here, basically inserting a different value under the same key will overwrite. So to the sender's balance, I say insert the balance they previously had minus the amount they have sent. Oh, that makes sense. It's cool. Remember that insert actually expects the second argument to be a reference, so we need to take the reference. Easy peasy. Now, for the recipient, I also need to check the balance just to be able to update it accordingly. And now, oh, I made an error. It should be a plus here in the last line. Sorry, I was making this look nicer today. I messed up the signs. Well, it should be a plus, to balance plus amount. So I insert the updated balance. But now, what I want you to take a look at here is basically the order of the operations. And it actually can matter whether you first increment the balance of the sender, increment the balance of the recipient, or decrement the balance of the sender. That's because assuming your contract would have more logic here, it's actually a choice of, and actually checking the balance is also quite important. So again, with the reentrancy or the DAO hack, in theory, if, for example, the middle balance off would fail, well, you would revert. But in some situations, if it called to another contract, you could be stuck in a loop that just drains a balance from one account or transfers to some other account. Basically, the order does matter. And now to the errors. Oh, by the way, if you're writing something on the chat, I cannot see it because I'm on full screen, and I'm not sure how to fit this all in one screen. Maybe let's just check for a quick second. Okay. I assume everything's fine.
I've been following it, so it's mostly fine. Yeah, the issues have been resolved between the participants.
That's amazing. Good people. Yeah. So I want you to now focus on the not the box, but the arrows, right? So what we return when there's an error and what we return when there's no error. So if you look at the signature of the function, so at the header, you will notice that it does return something called result, which will either give you a blank value, a unit value, or some PSP22 error, which we will define in a moment. So basically, the idea here is that instead of throwing some exceptions or interrupting the execution flow in any way with some special constructs, we basically return a value that, again, similarly to the option returned by the get from the map, this can be one of two things. It can either be okay and some value inside in case everything went as expected, or it can be the error. Sorry, it's very hard for me to pronounce, the error variant, containing some representation of an error. It doesn't actually have to be a dedicated struct inside. You can use a string, but using a struct gives you several benefits. So basically, let's see how we can define this custom error. Well, disregarding the scary looking macros at the top, which is basically, basically you need to be able to encode and decode the errors and compare to pass them from outside your contract and so on. But the important part is that you have this enum, which in this particular flavor basically gives you like a union type saying the error can either be insufficient balance or some custom error containing a string inside. Either this or that, or even maybe something else. Now, the result type is, of course, included with Ink, but the way you would implement it if you were to write it yourself, or basically if you wanted to learn the idea behind it, is, again, it's an enum with two variants, okay with some value inside, and error with some error message or representation inside. Now, the pointy brackets and the letters are basically type parameters that you might be familiar with from other languages. This is basically saying, okay, this result can basically have any type of value as the actual value and any type of error as the error. But of course, this is type type checkable. So if I define here that I'm returning a result with the unit value and the PSP22 error, then the compiler will check if this is actually the case once I return. Here, everything is fine. But yeah, the compiler is able to check that. What the compiler is not able to check is if you use this type, well, this is like a type alias kind of thing. If I say that, well, for example, if I always return a string as the error variant in my errors, I can just simplify it to say, okay, so my error is this specialization of my result that basically has any type I want as the value, but string as the error. And now this particular construct is not type checked. So this is basically just like a simple substitution, and my error and my result of t and string will not be distinguishable by the compiler. And if you compare that actually to the actual ERC20 standard, notice how much this kind of algebraic error handling makes our lives easier and our programs more robust. So basically, when a function returns a result like that, so doesn't throw an exception or doesn't do like revert or whatever you might do, or an assert, or one of these magic functions that basically revert the transaction. When I get a result like that, I need to handle it. So either say, okay, I'm explicitly returning this to the user, in which case it will be visible in my type signature of the function, or I need to assign it to something. But then in order to process it, I will need to handle both cases. So explicitly again, and arguably a lot safer. And of course, if I want the whole contract to fail, I can safely do it, right? I can even write panic and on the error variant, and everything will be blown up and the contract state reverted. But I can choose not to, and I can handle this because maybe this is an error I'm able to recover from, right? Like not finding something in a map is probably not reason enough to kill my whole execution. Now, yeah, so that's the idea, and I think this concept is probably reason enough to use Rust and Ink. But of course, there are more. But I love it. Yeah, a fun fact: this is also the standard way of handling errors in Haskell, for example. Yeah, so actually, we are nearing the end slowly, I believe. Now, when you have external parties interacting with your smart contracts, they will most probably want to know what's happening inside of your contracts. And of course, they can query the state using the methods, but sometimes you would just want to display what's happening in the contract as like an event log. Sometimes you want the external systems to react. For example, you can say, okay, if a transfer has been made to a certain account, then fire this piece of off-chain logic. So typically, the way to do it would be you start listening for the transfer events, examining their contents, and react accordingly. Most probably, to work this way, you will need an indexer. Just because it wouldn't make sense to kind of inspect all the blocks yourself. But yeah, the idea is that basically you create this surprise struct with an event macro. You should probably be very familiar with this whole concept right now. And you can include any fields you want inside. But if you, so the events kind of will form this sort of a log or a database table. So similarly to a database table, they can be indexable on a certain topic. This works. Actually, the intuition here is exactly the same as with a database index. So so it makes sense to index on the recipients and senders of the transfers, not necessarily the balance. And the interesting thing here the interesting thing here is that notice that both the from and to fields are optional, so the accounts. And yeah, this is a homework. In which case would you emit an event that, for example, has a sender but does not have a recipient, or conversely has a recipient but does not have a sender? Hint: these are the special kinds of transfers. Now, the way to emit an event in a very basic form is basically, again, using the self-env emit event method, and of course, creating the transfer. Now, this, like I said, this is very basic. In our documentation, you will find some examples on how to make it work better in a multi-contract setting and so on. Yeah, so one of the last things I wanted to mention is that, importantly, each contract actually is an account on the chain, which means it can hold funds, it can send funds, and it can receive funds. So, of course, you can do a regular transfer to a contract. You can also transfer some value as part of the call. It's called an endowment. And the way for your contract to actually be able to receive such an endowment is if, aside from being marked as Inc message, is also marked as payable, which means, okay, when you call this pay me function, you can also send some value along, and the contract can, inside the method's body, can check how much was transferred. And this is cool because, for example, you can charge some fees, right? So you can say, okay, I will mint you an NFT as long as you've sent me at least 100 A0, for example. Or you can take deposits or stuff like that. Now, you can also do the reverse. So you can actually initiate a transfer from your contract. And yeah, basically, again, with the env method, and you just transfer to a specific account any value you like. Of course, it can fail. For example, if your contract doesn't have enough funds to cover this transfer. Now, this will return some internal Inc error. What I'm doing here is, well, this returns a result, right? So either basically nothing, the unit value, or some specific error. I'm saying, okay, so return this result, but change the error for me. So I map a function over the error, which is actually a cool capability. The result actually has a lot of methods you can check in the Rust standard library documentation because it's the same. One of the abilities is to change the error. So I'm saying, regardless of what error was thrown, I just want to return my own custom error saying, okay, the transfer failed. But I would definitely recommend checking out the API of the result struct, because there's some cool convenience methods that can save you from a ton of pattern matching. Yeah, and obviously, it's I don't want to say it's a must. It kind of is, but it's a very good practice to include tests in your smart contract. So you have a few options actually right now. One of them is to basically write unit tests as part of your smart contract file. They are pretty much the same as regular Rust unit tests. So written directly in code, there's this inc test macro and so on and so on. And unit tests are cool for, quickly checking the very basic execution of your smart contract. Like each building block you probably should unit test. They are quite limited in functionality, but still very useful for very quickly checking. Now, right now in Inc, you also have the end-to-end tests, which allow you to test your contract fully. They are maybe slightly more challenging to write, but still, I strongly recommend writing them because, well, yeah, like a smart contract needs to be reliable and needs to be very thoroughly tested if it's to be deployed on mainnet, but actually even on testnet, it's good if no surprising stuff happens. Now, since I talked a lot about, and this is one of the last things, so don't worry, I'll end soon. Since I talked a lot about how awesome this result type is, you actually might think, okay, so if I have to chain a lot of operations that return some results, do I basically manually inspect each and every one of the results and therefore end up with like a huge tree of different pattern matches, ifs and conditions? Well, Not really. So like I said, first of all, there's a lot of convenient methods in the results on the results tract that you can use to make your code read very clean. But there's this somewhat magical, but not really, the question mark operator. So imagine, and this is quite a contrived example, but I think it is able to illustrate the cool stuff here. So let's say I have two functions that might fail, and both fail with different errors, right? They return roughly the same thing. So if they didn't fail, you would be able to like normally chain them. But here they return two different errors. And normally I would have to, like, okay, check if the first one was okay. By the way, this is how you inspect these variants in Rust with the pattern matching with match. Check the first one and return if blah, 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 blah. Check the second one. I panic here, but of course you could nest the pattern matches here and be more safe. But still, this is a lot of boilerplate. This is a lot to write. So basically, what I can write, and in order for this to work, I need to have these conversions from these errors to some common type of error. So for example, one error I would use as the common type of error is the custom, like catch-all error we defined a few slides back. But provided I have this from implementation, so it actually reads very intuitively, right? So from my error to my error 3 for my error 3, and basically I'm instructing the compiler how to convert an instance of one error into the other. Once I have that, I can say, okay, so now my function just returns the common error, and I write it like this, right? And it reads exactly as basically pure code. So you see just two operations, and you can trust that if any of the operations in the chain fails, the compiler will automatically convert the error to the like top level error, and actually fail the whole computation with this error. So it works very nicely. In some ways, this is similar to how you handle errors in like functional languages. So I think this is really cool. Yeah, now once we have this contract and we've built it and so on, we can deploy it to the chain. And I'm just, I try not to do live demos, so I made a few screenshots. So I basically have this account. You can read our docs on how to get set up with an account, but assuming you already have one. And here I'm showcasing deploying on testnet, but the procedure is exactly the same if you're deploying, for example, to Substrate Contracts node or to your local chain running on your machine, or actually even to mainnet. But I definitely don't recommend deploying to mainnet if you're just, developing. So yeah, I choose the contract bundle, I give it a name, I choose the account to deploy from because, well, I might have several. What it does is actually it checks whether the file is valid. Then what happens is, this is actually two steps at once. We upload the code, the WASM blob and the metadata to the chain, and are given a choice of all of the constructors here. Which one do we need to call to instantiate the contract? So in our case, this is just total supply. Okay, I give the initial supply. Now, there's this ref time limit and proof size limit, which is basically the limits on storage and execution time of your contract, because both will kind of influence how much gas you pay. But in, I would say, vast majority of the cases, you don't need to worry about setting these, because what this actually both cargo contract and this piece of software is doing. By the way, this is the contracts UI on the .substrate.org. But what this is doing is it's actually doing a dry run of your contract. So like a run that doesn't mutate any storage or something, but just will give you the estimates on how much gas it will need and so on. So it's most of the time it just happens automatically. And yeah, then you just up and instantiate it, and a transaction is made and so on, and you have a contract under an account that you can check here. You can actually also inspect its code hash and so on. And you can run some methods, of course, specifying the caller. You can view the metadata. And the metadata, by the way, is constructed from your code, meaning that the doc strings you write on your method will be visible here to the users of your contract. So it actually really pays off to write nice doc strings for Ink. And yeah, you can call any method, inspect the metadata, like I said. And some methods will not require signing a transaction. Just they can just inspect the storage, but if they mutate the storage, you will need to, of course, sign the transaction. And yeah, you also have the events in one of the windows on the side. And yeah, perhaps a quick shout out to Inkathon. So I definitely would recommend using this. I was going to say if you're starting out, but actually, no, whenever. Like if you're an experienced developer, you probably also want to use this, well, or something similar, but this is what I like, to basically, get a fully working, full stack dApp without needing to, carve everything out yourself. I'm very confident that this is written by very smart people and works very well. It gives you the wallet connect button, everything. So it's pretty cool. And yeah, we also are working on this cool library called Drink. Maybe I'm able to play the video actually. So this is the Drink CLI, but Drink basically is a piece of software, well, maybe a library or a framework for dechained execution of smart contracts. So what it allows you to do is basically play with your contracts without deploying them on chain. You can use it as a library in tests. So to do end-to-end tests, you can alternatively use Drink. And the huge advantage is that, first of all, it doesn't require you to do stuff like signing transactions and so on. But also, this is basically blazingly fast. I mean, Aleph Zero is a fast blockchain in and out of itself, but Drink is even faster. So it's really cool. It was created by one of our developers, and yeah, definitely recommend giving it a try. Actually, in the hackathon, we do give some like bonus points for using Drink in your submission. So definitely worth taking a look. But yeah. This would be it. Thank you for attending. Thank you for listening. Let me know if there are any. Stop sharing. How do I stop sharing? Stop sharing. And sorry, my screen went. My surroundings went dark. Basically, I didn't want to get up and turn on the light. So
I was just about to comment that once we started, it was you were perfectly visible, and by the end of it,
yeah, this is how
barely see you.
Sorry about that.
Yeah, well, again, really happy to have had you here and for this initial workshop. The one thing that I actually wanted to make sure is that, actually, let me just stop sharing this. And we actually have a few questions that it might be used if you can answer. One of them was just shared by Frank in chat, who was asking, so substrate storage uses scale to store variables more efficiently. To interact with the node, I have to encode it. And if I want to write it, I have to decode it. But if I speak to myself, I can use every format that I like. To follow the standard, it recommends to use encode decode from scale as well. It's like, is he on spot, or is he correct in this or not? That's what he's wondering.
Yeah, as far as I was able to follow, because I don't see the question here, but
you have to scroll up a bit. It's one of the latest ones.
So yeah, basically the whole substrate stack or concept using the scale, and it's actually very deeply rooted in how the palettes work and how palette contracts works. So yeah.
I will just bring a few questions from the question section to the screen, sure, so that you can go through them. One of them is coming from Mork.
Can I ask you some specific? How far through the roadmap A0 is? Well, I'm not sure what specific features you're looking for, but basically, as far as smart contract development goes, it's all feature complete. So you can use, everything you want. You can create any token types you want. Regarding, I kind of suspect this is regarding liminal. So we actually probably do not, well, we don't have a privacy bounty on this hackathon. So even though there's nothing preventing you from using like the developer preview of Shielder we have in our GitHub org, it's probably, I'm not sure I would go this way if I were you.
Well, just to shed a bit more light, Mork said he's asking about privacy in ZK, and he's not really sure about what liminal is.
Oh yeah. Private Shielder is basically one of our privacy primitives, and it's implemented. It's not live on any chain, just because we are not going to deploy it until we have the whole compliance/fraud prevention framework around it, because this is one of the biggest challenges in this area, I feel. So for this hackathon, I'm not sure I would really dive into the privacy features, but of course, if you want to give Shielder a look, or if you want to verify your own snarks at the chain, you will definitely you can do it. You can check out the baby liminal palette and extension, but like I said, I'm not. Well, this is kind of outside of the scope of this hackathon.
Yeah. Additional question from Frank, which is what are some good repos to look at Ink in production? And GitHub repos would be nice if you can suggest some.
Definitely check out the A0 ID repository. So I would even go as far as saying not only the repos, but also the project in general, like documentation, for example, and branding and everything. I feel like this is an example of how a project should be done in the whole package.
Right. One last also from Frank, who's asking what makes Ink contract special if I deploy my project there. So it's a general one, but still.
Yeah, sure. So unless you decide to use the baby liminal palette and double in privacy, to be honest, nothing that special aside from being really fast and really cheap. So if you're a smart contract developer, I feel like if you develop for a while, you'll come to appreciate it. And the privacy. So it's definitely our focus, but it's not something that is live right now. So you can use some development primitives, and I just want to say that I'm not involved in our privacy endeavors. So I would probably suggest, just taking a peek at our docs. There is some sections about Shielder. You can inspect the Aleph node repo for the baby liminal palette, but I'm probably not the best person to tell you about the privacy. Beyond that, we have a very strong team working on it, and some things are at the developer preview stage. Some things are being formalized as research papers, and some things are being implemented. And I think that's more or less the full picture.
Yeah. Last one just came in from Rick as well, who's asking if there's an Oracle on Aleph Zero that can be used for our hackathon.
There's one in development. It will be available really soon, but for now, I don't think you can use one.
Okay. Well, I don't think I see any other questions in chat which have not been answered yet. But
there's also one from Rico. Is Drink an alternative to the Inkathon starter pack? Definitely not. Drink is basically like an alternative backend for Ink, because usually Ink is designed to run on the chain. But in some cases, you basically don't need especially when you're developing or like playing with the contracts or actually even testing a lot of the contract functionality, you don't need the full chain with balances, with staking, with validators, nominators, and everything, right? There's a lot of functionality there, meaning quite a lot of overhead if you want to run it locally. So the idea behind drinks is, okay, if the contracts are predominantly talking to pallet contracts, why not just take pallet contracts and build around it with like a very thin API, and then you have something that you can use to develop really fast, basically. But this is not an alternative to Inkathon, because Inkathon is basically solving a problem. Okay, so I want to build a full stack Ink app. What do I use to get started? And Inkathon is saying, okay, you can just use this and then just modify the front end, but it's there. Modify the smart contracts, modify maybe even like write some backend logic, but yeah, it's like a scaffold. Yeah, thank you.
Questions for the drink, so the drink link, but Mork was fast enough. Another question that came in earlier during the session was, I'm just going to share it on screen, that I'm aware that the versions that can be a serious issue while building in Ink, and there's documentation out there that can help out to understand which are currently stable.
So I am not aware of anything beyond what I included in the presentation, and this is just like my personal trial and error. And I agree that it can be challenging. I basically attribute it to the whole Ink and Substrate ecosystem being very dynamically developed. So yeah, in Ink, well, I found that if I pretty much use the newest version of everything, it works. But when it comes to some other dependencies, you can also I also do the scale codec 2.9 if that helps with anything. So Ink 4.3.0, cargo contracts 3.2.0, Rust 1.74, and beyond that, I'm not sure if I can offer any more help, but we definitely are aware that this would be very helpful, and we will do our best to publish something soonish.
Great. Quickly checking in for last entries. Oracle, that was actually covered, so still being worked on. There's a question regarding what are the evaluation criteria for the hackathon. Again, we've shared additional notes within the hacker pack, so you will be able to find details not only on what the bounties entail, but additional information provided by all the bounty providers with details on things that they would like to see built, things that they expect from you, things that might be outside of the scope of the project, the hackathon, but definitely some bar that they would expect you to be above in order to be in competition for the respective prices. But yeah, I think this brings us to the end of this both launch and first workshop. There's going to be a lot more workshops coming in by both the end of the week as well as next one.
Yes.
So again, thank you all for being here. Thank you, Piotr, for this amazing workshop.
Thank you for being here. I hope. Sorry for sitting in the dark. This
is no
not
worries at all.
How I work. But yeah, I was too far from the light switch, and I wanted to keep it.
No worries. All good. I think everybody enjoyed it, and thank you for the elaborate Q&A in the end. I think it's really useful.
And I think I haven't joined yet, but definitely feel free to reach out on the A0 Discord. You will find the link on the on the main website. There's a link to our own Discord. Of course, the Encode Discord. I will do my best to join as soon as I can to also be there to answer any questions.
No worries. We'll make sure that, so everybody, if you have questions, do voice them in the Discord, and we'll make sure to connect you with both Piotr or members from the rest of the teams and get you answers, get your questions answered as soon as we can.
Yeah. Also, again, don't hesitate to ask the guys from A0 ID, because actually I believe they have a lot more experience writing Ink smart contracts than myself, so I'll be able to help the best.
Great. Again, thank you again, Piotr, and thank you all for being here. Hope you enjoyed it. This was an amazing kickoff to hopefully an even better hackathon. Looking forward to see you around soon. See you all. Enjoy the rest of your day.
Bye, everyone. Have a good one.